All right, so I think I was having some difficulty in connection. Uh, so let's see. I guess we are live right now. Uh, yeah, let me just double check. All right, so over here we'll quickly show. So I already did these problems when I was live on my OBS studio. So I guess it was not broadcasted here, but I'll just quickly explain what we actually did in the live session, and later on I'll just upload the video. So let's just quickly go over these problems. So these problems are actually coming up with some high level instructions, meaning if you don't understand the concept, it would be very difficult to solve these problems in DESMOS. So if you look at this first problem, it's n to the power of 5 over 3 is equal to k to the power of 2 over 5, and n to the power of 4a plus 1 is equal to k. What is the value of a? So I know that n to the power of 4a plus 1 is equal to k, which means k is equal to n to the power of 4a plus 1. At the same time, I also know that k to the power of 2 over 5 is equal to 5 to the power of 3 n to the power of 5 over 3. So what I need to do here is I basically need to convert this k to the power of 2 over 5 into k to the power of 1. And to do that, I just need to multiply this exponent with its reciprocal, which is 5 over 2. And I need to do this on both sides. So take exponent of 5 over 2 on both sides. So power of a power, we have to multiply these two numerators. So it's 5 times 5, which is 25. 3 times 2, that is 6. So I have n to the power of 25 over 6, and I have n to the power of 4a plus 1. So I can write this as n to the power of 4a plus 1 is equal to n to the power of 25 over 6. So I can just equal the two exponents. 4a plus 1 is equal to 25 over 6. I can quickly use DESMOS to solve this problem, but let me just show you how you can solve it manually here. So subtract 1 from both sides. I'm getting 4a is equal to this. This is 1 over 1. So I multiply this with 6 on the top and 6 at the bottom. And we have 19 over 6. Divide by 4 on both sides. We are getting a is equal to 19 over 24. And that is our answer over here. Now let's look at the second problem over here. So we have a problem involving functions. Now the trick here is that you need to understand that we are dealing with the vertex, so we have to get the vertex form. The vertex of the function f of x is given as 9, negative 13, and the point 3, negative 4 lies on the parabola. So if g of x is equal to 4 times f of x minus 2, what is the value of g of 0 minus f of 0? So we can see that for any vertex form, we can write this as f of x is equal to a times x minus h whole square plus k, and the vertex is 9, negative 13, so I can put this 9 for h and put this negative 13 for k. We have a times x minus 9 whole square plus negative 13. Now we can just plug this given point 3, negative 4 and solve for this unknown a. Remember, for any vertex form, we have three unknowns, a, h, and k. We need to evaluate all these three variables so that we can have the complete function. So I'm just plugging negative 4 for this y and 3 for this x. I'm getting a is equal to 1 over 4. Let me just show you how you can get this in DESMOS. So we have negative 4 is equal to a times 3 minus 9 whole square minus 13. Now I just need to get this a into x, just convert this a into x, and I'm getting 0.25, which is 1 over 4 in fraction, and that means a is 1 over 4. So now I have my complete function. F of x is equal to 1 over 4 times x minus 9 whole square minus 13. So my function is f of x is equal to 1 over 4 times x minus 9 whole square minus 13. So from here I can find my g of x. G of x is 4 times f of x, 4 times f of x minus 2. And I can now find g of 0. I can also find f of 0. And the problem is asking g of 0 minus f of 0. What is the value of that? So simply put this in DESMOS. G of 0 minus f of 0. You get 61.75, and that's our answer. All right, now let's move on to this problem over here. So we have negative 377x plus k is equal to 377x plus k. If k is a constant, how many solutions does the given equation have? So here is a quick trick. If you have a system of linear equations, we need to check whether the two equations have same slope and same y-intercept. If they have same slope and same y-intercept, they have infinite solutions. If the slope is same but the y-intercept is different, basically they are two parallel lines, they will have no solutions. And if the m is different, meaning the slope is different, it doesn't matter whether they have same slope, same y-intercept or different y-intercept, they will have one solution. So in this case, our answer is one solution. Perfect. Now let's move on to this last problem that we had discussed in the broadcast. So the problem statement says the perimeter of a right isosceles triangle is 76 plus 76 is square root of 2. What is the length of the hypotenuse? So for any geometric figure, it's always a good strategy to draw a diagram. So if you draw this diagram, you can see that these two legs would be equal. So we can just label this as x, and we can just label this hypotenuse to be y. And we know that these two legs, x plus x, and this hypotenuse y, if you just add them, it would be 76 plus 76 is square root of 2. So we can just isolate this y so that we can have these written in terms of x. So we have 76 plus 76 is square root of 2 minus 2x. So remember, x plus x is 2x. We are taking this 2x to the other side. And now we have this hypotenuse in terms of x. And since this is a right triangle, we can apply Pythagoras theorem. So that is x squared plus x squared is equal to 76 plus 76 is square root of 2 minus 2x whole square. Put it in the DESMOS. So let's see. We have x squared plus x squared is equal to 76 plus 76 is square root of 2 minus 2x whole square. And we are getting two answers, 313.22 and 53.74. Now remember that this perimeter is actually 183.48, so I cannot select this larger answer. So the x value should be 53.74. That is my x. Now the problem is asking to find the length of the hypotenuse, which is this y. So 76 plus 76 is square root of 2 minus 2x. So put it in the DESMOS. Minus 2x, x is 53.74, which is 76. So my hypotenuse here is 76. Perfect. That's my answer, and that's what we actually discussed in the broadcast. I hope these problems make sense. Now, a quick call to action here is, If you are having any problem with SAT math section, you can join my school community. It's completely free. You can connect with other students. You can post your performance. You can post your feedback. Also, you can take free diagnostic test to see where you actually stand right now in your SAT math section. The link is in the YouTube channel. Make sure to click that link and join the um, school community. It's completely free. And I'll see you in the next week. Same time, same channel, 12 p.m. Eastern Time on Wednesday. And I'll come up with some new exciting problems in the SAT math section. All right, that's it for this video. I'll see you in the next one. Now, let's get to study.